So this is 2017 paper 2 question 7. So here we've got cones is a sculpture in the National Gallery of Australia. It consists of 14 identical steel cones arranged in pairs. So there's 7 of these, but you can see cones are placed on top of each other, so that's why the 14 is coming from, and they're joined together. So first question here, they're asking you to find the height of each cone when it's equal to the diameter of its base. So if the radius of the base is 2.25, write down the height. So you know that the height is equal to the diameter of its base. So if the radius is 2.25, then the height is going to be twice that. So the height then is 4.5 meters. And that is 10 marks just for doing that. So for part 2, show that correct 2 decimal places the slant height, or L, of a cone is 5.03. So when you draw your cone, you have a radius of 2.25, and we know that the height is 5.03. So what we're trying to do is to find L here, which is the slant height. So that's actually a right angle triangle, so you can use Pythagoras Theorem, which is a squared plus b squared is equal to c squared. So a and b are just the shorter sides, so that's 5.03 squared plus 2.25 squared is equal to L squared, or c squared. So when you put that into your calculator, get 25. When you put 5.03 squared plus 2.25 squared, into your calculator, you get 25.3125, and then that's L squared. So to find L, then you square root that, and when you square root it, you'll find that your slant height here is 5.03 to 2 decimal places, and that is 5 marks. For part B, so in order to maintain the steel's reflective shine, the surface is polished regularly. So find the curved surface area of the entire sculpture. Remember, there's 14 cones. Give your answer correct to 2 decimal places. So the curved surface area in your formula tables is pi, or L, which is pi times the radius times the slant height. So we know that this sculpture has 14 of them. So I'm going to do 14 by pi, by the radius, which I know is 2.25, by the height, which is 5.03. Sorry, not the height, the slant height. So that's L from your previous question. So when you put that in your calculator, then you get to 2 decimal places 497.77 meters squared, and that is 10 marks. For part 2 then, we know that 1 litre of polish will cover 12.25 meters squared. So find how many litres are needed to polish the entire sculpture. Give your answer correct to the nearest litre. Well, we know that we need to cover 497.77 meters squared, and that each litre covers 12.25. So we need to find how many litres do we need. So we're going to divide, and that gives you 40.634. So when you round that to the nearest litre, you get 41 litres. That is 10 marks. So a container of polish contains 5 litres and costs 110 Australian dollars. Find the number of containers of polish that must be purchased in order to polish the entire sculpture, and hence find the cost of the polish in euros. So give your answer to the correct to the nearest euro. So we know that we need 41 litres, and it comes in tins of 5. So I'm going to have to find how many tins do I need. So I need 8.2 containers of 5 litres. So that means that I really need to buy 9 of the different containers. So if I buy 9 of the containers, then that's going to cost me 9 times 110. So that's going to cost me 990 Australian dollars. So the price here is giving me that $1 is 68 cents. So if that was €1 wasn't so many dollars, you could divide. But because you have $1 is 68 cents, you're trying to change it to euro. So you're going to do 990 multiplied by 0.68, and that will give you how much it is in euro, and that gives you €673.20. They want you to round it to the nearest euro, so that is €673. That is 10 marks for those two parts there. Okay, so what you need to realize here is that with this cone, is that it has a radius of 2.25 and that it has a height of 4.5 and a slant height of 5.03. So that's the first thing you need to realize. So here they're asking you to find the length of the arc of the sector, giving your answer correct to 2 decimal places. So here you're trying to find the circumference all the way around. So circumference is equal to 2 by pi or the radius, or 2 pi r. So here I know that 2 goes in, pi goes in. The radius is the confusing part. The radius is actually 2.25 here. Don't use the 5.03. That is the slant height. Loads of people will make a mistake with that. When you put into your calculator then, you get 14.14, and that is in meters, okay? Because although they're talking about the arc, the radius of this actual cone is 2.25. Now, to find the angle of the center of the sector, show all your working out, give your answer correct to the nearest degree. So if you're looking for the angle of a sector, you usually put the angle over 360, and then you multiply it by 2 pi r. So we don't know what the angle is, and we put that over 360, and we know that this actual answer for the arc length here is 14.14, so I'm going to make it equal to 14.14, and then I multiply the angle over 360, multiply by 2, multiply by pi. Now the radius of this arc is 5.03 this time. Make it equal to 14.14, so then you're trying to find what the angle is. So try and simplify what you can. So what we can simplify so far is we still don't know what the angle over 360 is. We can put into our calculators 2 by pi by 5.03, and when we do that, we get an answer of 31.604, and that's equal to 14.14 still. So in order to find the angle over 360, I am going to divide 14.14 by 31.604. And what I can do then is, once I have that, is I can do the angle is equal to, once I find what 14.14 is, divided by 31.604. I get 0.44. So 4474. So I'm going to round that up to 0.45. If that's over 360, then just multiply that by 360. And that gives you a final answer there of 161.07. So to the nearest degree is just 161 degrees. And that is 10 marks for that answer.